At this point, you should know how to set up a cut with proper vicing, guide arm placement, tension, and sawing fluid. Now, let's take a look at the powers at play when bandsawing. To do that, let's look at a simple example from everyday life. Let's say you're digging a hole with a shovel that can only hold a specific amount of dirt. You can control how quickly dirt is removed by how quickly you move the shovel. You'll need to push with a certain amount of force into the dirt to fill your shovel to the correct capacity. Overfilling the shovel will slow you down or break your shovel. Filling too lightly will lengthen the amount of time it takes to complete your hole. Ultimately, you want your shoveling speed to be in balance with the force you have to expend to fill the shovel in order to efficiently dig. Let's see how these same factors are at play in your bandsaw machine. In our digging example, the shovel is the same as the tooth of a bandsaw blade. Each tooth can only hold a specific amount of material in its gullet. The tooth penetrates the material, pushing a continuous chip of metal from the workpiece. In order to create an optimal chip, you must use band speeds and feed rates to efficiently load the chip. Just as with digging, finding a balance between the feed rates to fill the gullet and the speed is what creates efficient cutting. Band speed refers to the rate at which the blade cuts across the face of the workpiece. With digging, this refers to the speed at which the shovel head moves. For our purposes, band speed is usually expressed in feet per minute or meters per minute because it represents the full length of the blade that runs through the material in a minute's time. When digging a hole, how quickly you can load the shovel depends on how heavy or compacted the dirt is. In this same way, band speed is completely dependent on the material being cut. The harder the material, the slower the blade will be able to travel. The softer the material, the faster the blade will be able to travel. In these videos, you can see how 1018 carbon steel with higher machinability will cut at a faster rate than 304 stainless steel. This is because softer materials like 1018 with high machinability will be able to handle faster band speeds. Faster band speeds lead to faster cutting. But if the band speed is too high for a specific material, it will produce more heat and will limit blade life. The next control that is at work when cutting with a bandsaw machine is feed force. Feed is the ability of the blade to travel through the material being cut. Feed force is how much pressure is used to push the tooth tip into the material. Feed force is measured in pounds per square inch, also called PSI, or bars. Often, feed force is just simple gravity pulling on the weight of the machine head, because not all bandsaw machines will allow for automated changes. In these cases, it is not uncommon to see extra weight applied to the bandsaw machine head in order to increase the pull of gravity. In general, higher feed force will allow for faster cutting, but this is dictated by the machinability of the material being cut. Feed force works in conjunction with feed rate, so you'll need to find a balance between the two. Feed is the ability of the blade to travel through the material being cut. Feed rate is the speed that the blade travels through the material. It is measured in inches per minute or millimeters per minute. In order to cut quickly, you will want to remove as much material as possible as quickly as possible. To do so, you'll want a high feed rate.